In this video, we will be covering two sections, 1-6 and 1-7, and we will be solving equations. So by the end of the video and work time in class, you should be able to say, I can solve equations by adding and subtracting and then also multiplying and dividing. We're going to look at a visual representation here. So we see in that visual representation how we have a balance, and we're looking at everything on the left was the same as everything on the right when it was balanced, and then when it wasn't balanced it was different on both sides, and that's giving us a visual representation of an equation. Some vocabulary here. First, we'll start with an equation. I would like you to write a mathematical sentence with an equal sign. It's key now that we're looking at sentences, and a sentence will give us that equal sign, where if it was an expression we wouldn't have that equal sign. We will be looking for solutions to these equations, any value that makes that equation true. So we're looking at making that equation true. And to do that, we're going to isolate, which means to get the variable alone on one side. We're going to be following properties of equality to isolate the variable. First, the addition property. If you add each side of an equation by the same number, the two sides remain the same. This is saying whatever you do to one side, you must do to the other side to remain the same, just like in that balance. If we added a dice to one side, we would have to add another dice on the other side for it to be the same. Same is true with subtraction. If you subtract each side of an equation by the same number, the two sides remain the same. So here in example 1, we have 8 equals the opposite of 7, or -7, plus m. And the whole point of this is we want to know what m is to make this sentence true. Well, I see I have my equal sign right here, and I want to get the m all alone on the right side so I can figure out what that m is. So to figure out what m is, I have to get rid of this -7. The opposite of subtraction is addition, so I'm going to add 7. And whatever I do to one side of my equal sign, so here's my equal sign, I have to do the same to the other side. And I'm going to draw a line because I'm going to be simplifying here. My equal sign is going to go right below where it was. Now that the visual representation in the equation showing if I add something to one side, I have to add that same thing to the other side. I'm doing that here in an equation by adding the 7 to both sides. And the reason why we're adding 7 is because we're adding opposites by doing -7 plus 7. And when we add opposites, we get 0. So I would be left with 0 plus m on the right side. And then on the left side of my equal sign, I have 8 plus 7, which gives us 15. Well, now I'm going to simplify this more. If I have 0 plus m, that just means the m is all alone. And so we have solved this equation. The solution would be 15. 15 will make this statement true. We can go up in algebra and check our work. So let's take that original equation, 8 equals negative 7 plus, and we're going to replace the m with 15. And what we see here is that we have 8 equals negative 7 plus 15, which is true, because negative 7 plus 15 is 8. It's the same on both sides. So that means this is the correct answer. In the second problem, I want to get the t all alone. To get the t all alone, on the left side now of the equal sign, to get that t alone, I have to get rid of the negative 61. Now in front, because I have a negative, the opposite of that, I look at as subtraction. The opposite of subtraction is addition. You do the opposite. We do the inverse operation. Whatever we do to one side, we do to the other. My equal sign is going right below where it was. Now negative 61 plus 61, when we add opposites, we get 0 plus t. And 23 plus 61 gives us 84. 0 plus t is t. T equals 84. Here's our solution. Before going on to the next problem, we come up here, plug it into our original. Negative 61 plus t, which we're saying is 84. Is that the same as 23? And I know negative 61 plus 84, I find the difference, keep the sign of the greater. It's the same on both sides, so this means this is correct. N plus 15 is the same as negative 12. I'm going to, on this one, isolate the n, get the n alone on the left side of the equal sign. I want to get rid of the plus 15. And you do the opposite. The opposite of adding 15 would be subtracting 15. This here is 0, so now the n is all alone. I'm not even going to put plus 0. Now on the right side we have negative 12 minus 15, which is the same as negative 12 plus negative 15, which gives us a negative 27. So we circle our solution here. And we go back up and we check our answer by plugging this into the original. So we have, let's see, negative 27 plus 15 equals negative 12. And we check our work. Negative 27 plus 15, you would find the difference. 27 minus 15 gives you 12, and it would be a negative. And that's the same on both sides, so this is correct. Negative 82 is the same as r minus 36. So on here, here's our equal sign. We want to get the r isolated on the right side, so we need to get rid of this minus 36. The opposite of minus 36 is add 36. That's going to take away our negative 36. Well, whatever we do to one side of the equation, we do to the other side. Equal sign goes right below where it was. This simplifies to 0, so we would have r plus 0. The r is now isolated. Negative 82 plus 36. Since one is negative, the other is positive, in terms of these integers, we subtract. So I'm going to borrow and subtract. Keep the sign of the greater. Here's our solution. Check it. Plug it into the original. So we have negative 82 equals negative 46 minus 36. Negative 82. If I make this an addition problem, I get negative 82. It's the same on both sides, so this is correct. Now we're going to look at some more properties of equality. We have the multiplication property of equality, which is the same as addition and subtraction in the sense that whatever we do to one side, we do to the other. If you multiply each side of an equation by the same number, the two sides remain equal. Same with the division property. If you divide each side of an equation by the same number, the two sides remain equal. There's more than one way really to represent algebra. We saw the visual representation of the balance. Now in this problem I want to show you how without a balance you can look at things more than one way. It says 1 out of 3 students at school likes gym. If 120 students like Jim, how many students go to the school? Well, I have a picture here. And in my picture, I made 3 squares. And now it says in the problem that 1 out of 3 students at a school likes Jim. So if I have 3 squares, one of the squares is going to represent 120. 1 out of 3, it said 1 out of 3 like Jim, and it says 120 students like Jim. So in my picture, I have 1 out of 3 squares highlighted, and we know that that's 120. Well, if there's 3 squares and there's 120 in all 3 squares, how many total is that? That's our answer, 360. Well, another way to see it is with an equation. The number, the population, P, the population, divided by 3 gives us the 120 that like Jim. So if you take that whole population of the school and divide by 3 for 1/3, it's 120. Well, if I solve for P, now the opposite of division is multiplication. Whatever I do to one side, I do to the other. And if I multiply by both sides by P, what happens is this simplifies to 1. So the population of the school is 120 times 3, which is 360 for our population. So we can see 360 for our population in the picture, and also with using an equation to represent the problem as well. In this example, we want to get the W all alone, and the W is sitting right next to the -12, which means multiplication. You want to undo the math. You want to do the opposite. So if it's multiplying, to get the W alone, you do the opposite. You divide. Now you're going to divide by the number that the W is being multiplied by. And if it's a negative, make sure you divide by the negative. Whatever you do to one side, you do to the other side. This simplifies to 1. So I'm left with 1W. But if I have 1W, I don't write the 1 in front. The W would then equal -60 divided by -12, which gives you a +5, since a negative divided by a negative is a positive. Then we go back and we check our work, and we plug in 5. So we have -12 times 5 equals -60, which is true on both sides. So this means that this is the correct answer. In this problem, I have to get the N all alone on the left side of the equation sign right over here. Now the N is being divided. This right here, this line means divided. It's being divided by -3. Now I want to undo the division. I want to get rid of the dividing by -3. The opposite, I'm going to multiply by that -3. Whatever I do to one side, I do to the other side. And the reason is because this is really -3 over -3, which simplifies to 1. So I'm left with 1n, which equals -27. Check my work. Come over here, plug it into the original. So I'd have -27 divided by -3 equals 9. Simplify both sides, it's the same. So that's the correct solution. 5x is the same as -20. To get that x alone, you're going to divide, because 5x means multiply, opposite of multiplication, division. Divide both sides by that number you're multiplying the x by. That simplifies to 1. So the x is alone. You get -4, following your integer rules. Don't forget, go back, check your work. 5 times -4 is the same as -20. So that's the correct answer. Another problem, -2 is the same as r divided by -16. We want to get the r alone on the right side of the equal sign. We got to get the opposite of division, multiply. You multiply whatever we're dividing by. Whatever you do to one side, you do to the other. This simplifies to 1, so you have 1r. A negative times a negative gives you a +32. Check your work. Plug it into the original equation. -2 equals 32 divided by -16. Simplify both sides all the way. It's the same on both sides, so that's the correct answer. Can you say, I can solve equations using addition and subtraction and also multiplication and division? Please work your output out on your or in your notebook for the day and be prepared with questions for in class.